In an Aerospike database, cluster formation is dynamic and automatic. Agreement of the nodes participating in the cluster is maintained through the cluster management subsystem. When a node leaves or joins, the nodes determine the principal node, used during cluster changes, which then decides and communicates new cluster membership that the other nodes agree on. This entire process is able to happen without manual intervention. Once consensus of the cluster view is reached, partitions are distributed across the cluster based on namespace configuration, and a deterministic algorithm is used to map records to the correct partition every time. The exchange of a lightweight heartbeat, by default every 150 milliseconds, allows each node to track every other node in the cluster. This ensures any changes are identified by all nodes and helps to maintain cluster integrity. Commonly, the heartbeat is exchanged between nodes using TCP/IP, where each node establishes a connection to all other nodes. Alternatively, nodes may exchange the heartbeat through multicast, where the heartbeat is sent to a router which broadcasts to all nodes. But this is not supported in many environments, such as cloud providers. Beyond the heartbeat, nodes communicate with each other regarding replication, migration, proxies, and more to ensure availability and consistency of data, even in the face of failures. These intra-cluster communication channels are referred to as the fabric. The fabric has the ability to stretch across multiple sites geographically. The Aerospike Cross-Data Center Replication, or XDR, asynchronously replicates cluster data over multiple clusters and is commonly used for disaster recovery, regulatory data locality requirements, fast local writes, and greater site autonomy. Applications using the Aerospike API utilize the integrated Aerospike Smart Client, allowing the application to ignore node management while the client handles communication with the cluster. This client library used by the application talks to the Aerospike server over TCP/IP using a wire protocol, connecting through one or more seed nodes to discover the rest of the cluster. The client then opens a direct connection pool to each node in the cluster. All Aerospike traffic using TCP/IP has the ability to be encrypted through TLS, while the fabric and client-server communications, including XDR, can also be compressed. In the event a node unexpectedly goes down, a new one is added, or expected maintenance occurs, the other nodes are able to quickly identify the change and automatically rebalance and migrate data with minimal to no impact on your application. While the cluster is changing, the Aerospike Smart Client pulls the nodes and builds the new partition map as your application carries on. This self-managing structure allows Aerospike to minimize impact on service, while keeping application logic simple when cluster changes occur.